Hi everyone, welcome to Mostly Math. Today we'll be simplifying this unusual looking trigonometric expression. We're going to derive some expressions related to the Pythagorean identity to do this, so let's get started. Look at this term. This term seems to be the odd one out. We have a single trig function everywhere else, so we'd like to see if we can investigate this further. So let's start with the Pythagorean identity. We know that 1 is equal to cosine squared x plus sine squared x from elementary high school, of course. You've seen this before. What you haven't seen, though, is if we square both sides, we can get some interesting looking results. If we square both sides, it is cosine squared x plus sine squared x squared, which we can also rewrite as cosine to the fourth x plus 2 cosine squared x sine squared x plus sine to the fourth x. And now 1 is equal to this. And we have a 1 up top here. So we're just going to simplify that as follows. Actually, this is all a note, really. It's a sidebar. So now we have 1 over cosine to the fourth x sine fourth x is equal to this, divided by that, of course. Cosine fourth x plus 2 cosine squared x sine squared x plus sine to the fourth x over cosine 4x sine 4x. And we can see we have some simplifications. These are going to cancel. So it's 1 over sine to the fourth x, first term. The second term, we're going to have 2 on the bottom. So 2 over cosine squared x sine squared x. The last term, sines are going to cancel. 1 over cosine fourth x. And now what we're going to do is plug this into our main expression. I'm going to skip a step and combine some terms since I have limited space. Okay, let's look at the cosine to the fourth x denominator. Well, we have sine to the fourth x and we have 1. So 1 plus sine to the fourth x over cosine to the fourth x. And the new term here stays as is, no simplification for that. 2 over cosine squared x sine squared x. And for the sine to the fourth x denominator, we get a 1 here, and we had a cosine to the fourth up there. 1 plus cosine to the 4x over sine to the fourth x. Okay, it's looking better. We could stop there if we wanted to, but we can make an even simpler looking expression by doing the following. We're going to break this up. We're going to take these two simple terms, 1 over cosine fourth and 1 over sine fourth, and then add them, put everything else over a common denominator. So let's do that. Right. So this is the sidebar here. Now this is the main result. 1 over cosine to the fourth x plus 1 over sine to the fourth x plus something over the common denominator, which is going to be cosine fourth sine fourth. All right, let's get started here. So, taking care of this term. Next term is this one, sine fourth over cosine fourth. Well, that has a cosine fourth, so it needs a sine fourth. So it becomes sine eighth. Sine eighth x. Okay, this term needs 2 of each. Plus 2 cosine squared x sine squared x. And we did this term. This term needs a cosine to the fourth. So it becomes cosine to the eighth x. Okay, this looks pretty bad. So we would like to simplify further. It would be nice if we could get some of the cosine fourths to cancel with things on the top. But we have 8s and 2s, which just creates more sines and cosines. So we need some more strange trig identities to proceed. We can do that by squaring both sides of this identity. Okay, we got it squared here. And then we want to do the following. Just eliminate what we did before. Let's put the next trick here. Okay, we're actually going to multiply both sides by cosine squared x minus sine squared x squared. You'll see where we're going with this soon. Where x minus sine squared x is equal to, see, that came from the 1 over here, multiplied it. And now I multiply this by this, so it becomes cosine squared x minus sine squared x times, I'm running out of space, sorry. Now we have cosine squared x plus sine squared x. And this is all squared. And we can obviously see that we can get rid of some cross terms. We've got cosine of the fourth, that's cosine squared, sine squared. It cancels with that. We get the sine to the fourth over here. So we simply get this becomes now cosine squared x, no, cosine to the fourth x, sorry. That's the whole point. Minus sine to the fourth x squared. Okay, we have this. This is good. Now we're going to expand both sides. And this is squared. This is it's extremely tricky stuff, okay? These are very unusual things to do when you're trying to prove trig identities. So if there are any steps you have questions about, leave a comment. I'm sure this is all right though. I hope it's all right. Okay, let's continue. We have cosine of the fourth x minus 2 cosine squared x sine squared x plus sine to the fourth x on the left being equal to cosine eighth x minus 2 cosine of the fourth x sine fourth x plus sine to the eighth x. Okay, did I expand all those correctly? Minus 2 of each plus sine. Okay, now we have 8 and okay. So back to here, we have 8, 2, 2, 8. We can rearrange this expression to get what we need. We're just going to put this term over here, put this term over here at the exchange of a plus sign. So we're going to edit. And these 4s become 2s, and the 2s become 4s. Okay. Sounds good. Notice the right-hand side is exactly what we want. It tells us that if we have this pattern, we can simply replace everything by 4s. So let's go ahead and do that. Okay. And take a step for yourself if you're watching this and work this out for yourself, because it seems like magic. I'm just changing all these 8s and 2s to 4s, but 8 minus 2 is 6. So there isn't any reason why it should work out. It just does because of the Pythagorean identity, which we talked about. So feel free to work it out. Okay, so we can now change all these 8s and 2s to 4s up here, which is pretty cool. 4, 4, 4, 4. And now we get everything to cancel just like we want. So it becomes terms that we had before, plus 1 sine fourth x. We had these terms, new terms, we get the sines canceling over cosine of the fourth. And then this term, everything cancels, so it's just 2. And this term, we get the cosines canceling. And notice that everything is something that we already have. So there's a common factor of 2. And this is the result. 1 over sine cosine plus 1 over sine to the fourth x. This is the result as it was simplified in the textbook that I got it from. You're asking, how can anyone possibly use this? Well, Quantum field theory uses this identity in the final step of the electron-electron scattering. Electron-electron scattering. And it is related to the differential cross-section that is so important in quantum field theory. If you want to know about more, definitely check out Anthony Z's book, chapter 2.6. Somewhere in there. And yep, if you enjoyed this, want to see more, please subscribe. See you next time.